Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 109. It's on wave interference. In other words, what happens to waves when they hit objects or hit other waves? All the animals pictured here use echolocation. What does that mean? They generate sound waves that reflect off objects, and when they come back, they can figure out what they're looking at. Now, waves will also hit other waves, and as they do, sometimes the overall wave becomes larger, and sometimes it becomes smaller. So let me give you an example of that. I've got a slinky here, and I'm going to send two waves towards each other. Watch what happens when they meet, so the wave becomes bigger. But did the waves bounce off each other, or did they move through one another? Well, it's kind of hard to tell. Since both waves are on the same side, we don't know if they bounced back or if they went through. So a better way to figure this out is to send waves on either side. So I'm going to send a wave from the left on the top and from the right on the bottom. You can see they interact, but now the wave on the bottom continues to the left. And so when waves hit, they interact, but they move through each other. They're not reflected off of each other. And so wave interactions can take place when a wave interacts with an object, hits an object, or hits another wave. So when that interaction is with another object, we get reflection. It bounces back. Now, it depends on what we're hitting as to how we bounce back. And so if it's a fixed object, the wave, for example, the slinky hits something that doesn't move, it'll actually be inverted when it comes back. In other words, the wave goes in this direction, it's on the top, and when it comes back, it's going to be on the bottom. That's only if it's a fixed object. What happens if it's a free object? Well, the opposite happens. And so as it comes in now, let's say that this is able to move back and forth. The wave comes in on the top and it goes back on the top. And so that's reflection. Now when waves hit each other, we get what's called interference. Two waves interacting. That interference can either be constructive. Constructive is when two waves comes towards each other and they're both on the top. So what do we get? When they hit, we get one big wave. We're adding those waves together. So we're constructing a bigger wave. If it's destructive, we're on either side, and what do we get? We cancel each other out. So we are destroying the size of that wave. And so we use the law of superposition to figure out how big that wave is. And it's really easy. If you're 1 centimeter on top on both of those waves and it's constructive, we just add 1 plus 1 and we get 2. And so as waves bounce back and forth, what we can do is we can build up what are called standing waves. Waves that appear to not move, but what they really are is the addition of the waves bouncing back and forth. And so let's look at this using a PHET simulation. Let's start with a fixed end. So remember, if it goes into a fixed end, watch what happens. As it comes back, it's inverted. So it went down on the top and it came back on the bottom. Watch what happens if we now change that from a wave interaction where we have a free end. So it has the ability to move up and down. It comes back on the same side. And so again, it depends on what we're hitting as to how we come back, but we are coming back. We are being reflected. Now let's move into interactions between waves, when waves hit waves. And so that can be, remember, constructive or it can be destructive. And so let's start a wave moving down. So let me pause it for a second. Do you remember what's going to happen? We're hitting a free end. And so what's going to happen to that wave when it comes back? You should have said it's on the same side. And so let's do that. We were right. But you can see that I also generated a wave that's now moving from the left. These are about to hit each other. And so what's going to happen as they interact? Well, we should see constructive interference. And let's watch what happens. So we get one big wave right when they come together. Now what's going to happen to the wave on the left? Well, it's hitting a fixed object, so it should be inverted, and the one on the right should hit an object that's free, and so it shouldn't be inverted. So now what's going to happen when they hit? Should have figured this out. This is destructive interference now. And so watch what happens when they hit. They should cancel each other out. And we can just see this reflection and interference and reflection again. Example of this, I'm going to take a slinky and really send a pretty big wave. We'll do this in slow motion. You can see I kind of almost knocked my camera over. So the wave is moving to the left. It hits a fixed object and it was inverted. It hit my hand, which is a fixed object, and then it's going back in the other direction. So that's going to be that reflection of the wave. Now what will happen is if those waves keep bouncing back and forth and back and forth and back and forth, they're adding to and subtracting from each other, and so you get what are called these standing waves. And this is a SimBucket simulation. So you can see the green wave just appears to stand there. It's not moving. But what's really happening is that we have waves moving back and forth. So we have a blue wave that's moving to the right. It's reflecting back, and then it's moving to the left as this orange wave. And so as they move, they are interfering with each other. And so let's just grab one section right here. So why is this low? It's because they each are moving down from equilibrium, and so we just add those two values up. Why is the green right here at the middle? It's because we're above and below, and so we have destructive interference here, but we'd have constructive interference right here. In other words, we're building up that wave. Now we take advantage of that, so we can put sound waves that fit into a specific set length, for example, a pipe in a pipe organ, and you create what are called these harmonics of standing waves. And we'll talk about more of those in future videos. And so did you learn to make claims about what happens when waves overlap? Remember, they go through each other, but they can interfere. And then finally, could you look at a representation and figure out points when they're adding and when they're subtracting from each other? I hope so, and I hope that was helpful.